time and discrete time Fourier transform. But since for final exam and even for assignment, it's covering only for continuous time Fourier transform, so I'm going to only cover for continuous time only. So discrete time will not be covered, but it will be almost the same concept like what you have learned in Fourier series. Okay, so same, almost same, just that maybe the equation is a bit different. Okay, but if you feel that you are interested to know about discrete time, then you can go to my slide. It's in the slide already for discrete time Fourier transform. Okay, so basically for Fourier transform, there are two things that you're going to learn. One is the Fourier transform, and another one is that inverse Fourier transform. So both for Fourier transform and inverse Fourier transform, we have for continuous time and discrete time. It's similar like Laplace. You have learned Laplace, right? So Laplace have Laplace transform and inverse Laplace transform. And for both of these, you're going to directly use the table, right? You have a table that you refer to. So supposedly, if you understand the concept of Fourier transform, it's going to be easy because you need to refer table. Just that for Fourier transform, most of the question that you go to final exam and even for your assignment will be in analysis of circuit, okay, using Fourier transform. So you need to have the basic background on electrical circuit. Okay, so that will be the challenge for Fourier transform. Right, so this one just skip. So this we go to maybe very fast. So we have the two Fourier series pairs. So we have XT and AK. These are the pairs that you already know before. Okay, and for Fourier transform only have two pairs also for continuous time. So we have the first one underneath here. Look at the below part first. So the first equation here is, we call it as the Fourier transform equation. Okay, why? Because if you look at the equation, it's x j omega. Basically, you're going to do analysis similar to Fourier series. You did the analysis, you convert from time domain to continuous to frequency domain. Okay, why frequency? That's why for Fourier series you have the omega, right? Omega. Okay, and basically all of the question is given xt. So in terms of time domain. So similarly, this equation, why it's called the Fourier transform? Because in the equation is that you need to find xj omega, which is the signal for xt in terms of frequency domain. So it's given by integration. You see again integration, integration of minus infinity to infinity xt. So whatever value you have xt, a constant value, random value, then you are going to insert it into here, and e minus j t dt. Okay, so difference between the Fourier series pair is that you have k, right? For Fourier transform, no, we don't have that because you are not going to find the Fourier series coefficient. We're going to directly use this as equation. Second equation is that the name Fourier inverse Fourier transform. So basically how you write it is that ft for Fourier transform. Second equation is that Fourier transform coefficient inverse. Okay, so if you learned Laplace before, Laplace, you write it as Laplace, right? And then for inverse Laplace, it's like that. The same thing. For Fourier transform, the short for it is Fourier transform, and for the inverse is ft minus 1. Okay, so inverse of it. Right? So both of this, at the beginning of Fourier transform, I'm going to show to you that we are going to prove the table. So at least you know that, oh, this is how Fourier actually get the transformation table. Okay. So this is what it means. So basically you have in time domain given xt. So when you want to find the signal in frequency domain, so for this case is that you are going to use Fourier transform. Good. So it becomes x omega. So basically t become omega. And if you are given h omega, okay, if the question is to find the signal H in time domain, then you need to use the inverse Fourier transform, similar like Laplace. Okay, similar like Laplace. So it's interchangeable basically. Okay, so for this, convert from frequency domain to time domain, you are going to use inverse Fourier transform. Okay, so okay, this one is the example that we did yesterday for Fourier series, right? Okay, so if you remember, for Fourier series is for aperiodic signal. Aperiodic means that, and that's the reason why you need to find the Fourier series coefficient. Okay, and for Fourier transform is for aperiodic. So basically, for this is, we call this as periodic signal. Means that what? It's repeating. The signal is repeating. Second signal, third signal, and basically it's repeating to infinity and minus infinity. So this is what you call as periodic. So if we have periodic signal like this, which transformation you use? Fourier series or Fourier transform? Series. Okay. So but right now we are in chapter 4. Okay. So basically, look at the graph. What happened? Dia hilang kan? Okay, dia go missing, right? So basically, when you convert from periodic to aperiodic, if periodic is basically it's not repeating, you are given specific signal, and specific signal is between a time value lah. So when you have signal like this, whereby you don't have it going to infinity, maybe it's not going to have this be this simple. Maybe it's have a plus and a ramp here. So it can be any waveform. Okay. So if you have this type, then this we call it as aperiodic because it's not repeating again. Unless it's repeating, then it's periodic. Okay. So for this, you are going to use Fourier transform. So right now, okay, I'm going to use the tab. Okay. Sedap duduk ingat diri. Okay, let me just reassign this. I don't have this. Okay, we break at 12, but right now I go to this one first. Okay, let's look at this slide in front. I'm going to face you because I want to see if your face blur or not blur. And then you look at here. Okay, so basically what you did yesterday, if you remember, okay, so what we did was we did this signal. This one, it's a periodic signal, right? Periodic. And the time is between here to here. But basically, you have only a value 1 between minus t over 4 to t over 4. And this is what we did yesterday, right? So what you do, okay, basically what you do is that you find the value for a k value. We start with DC term, k equal to 0. So k equal to 0, a0 you get 1 over 2. And then you proceed to find the harmonics. Harmonic means that for k not equal to 0. So for the harmonic not equal to 0, what you do is that you proceed to actually substitute the value of t and the amplitude here 1. Okay, you do all of this, blah, 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 pop. You get the answer, right? So we did get this answer. Okay. Get this answer. And then you draw the magnitude and phase spectrum. And yesterday I mentioned that this signal connection is a sync. S-I-N-C. Is it correct? Sync. Sync. S Sinc theta is sinc. Sinc theta is sinc theta divided by over theta. Okay, so sinc means that it looks like this. If you Google, try to Google now. Sinc, signal sinc. Try to find it. So sinc, what does it look like? Sinc. Dah jumpa. So is it same? It's almost similar like this. So for Fourier transform, you will always refer to this type of sinc plotting later in this Fourier transform. Okay, so right now, okay, and then yesterday we proceed to actually find the equation in terms of sinc, right? If you remember, sinc. Okay, so let's go through this signal. Okay, so basically, okay, from this point, okay, everybody in? Everybody in? Okay, the exercise just now, hold first. I'm going to draw again because just now I was like reading the slide kan. So, which is like, maybe some of you are not following. Okay, so I'm going to write it so that you can write it with me. Okay, for Fourier transform, basically what you have learned is that if you have a signal, okay, a square wave just now. So square wave means that you have a square wave rectangular signal. We call it as, this one is rectangular signal. Okay, so center here is 0. So basically it's like a cosine wave. It's not starting at 0 but in center. Okay, so and then you have here basically example. Let's say example, you have from t minus t to t, and amplitude is a. Okay, a. So if I draw this out, it's like this. So this is xt, and then this is t. So this is in time domain. So in Fourier series, you want to convert it into frequency domain. Okay, right? X omega. Okay, so what's the plotting? So that's the question just now. So basically you can directly refer to a table. Okay, so the table that based on the Fourier transform, if you see the signal is given by a rectangular, okay, you directly refer to the table Fourier transform. Okay, continuous time, this one. So look at this rectangular t over tau. Or if you look at my notes, it's in the notes, is this one. Okay, this one a rectangular t over tau, or capital T lah. It's very hard to actually sebut t over t because it's t and t. So that's why I normally say it as t over tau. Tau is basically capital T. So the equation is a, okay, rectangular, okay, t over tau. Okay, from today onwards, capital T is called tau. If not, I need to say t over capital T. T small cap to t capital cap. So it's kind of confusing. So and to convert it, you are using Fourier transform table. Okay, directly you can use a t sinc omega t omega t over 2 t over 2. Okay, so t over 2. Okay, so t over 2 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 t Okay, so when you have that, so basically you see that, oh, there's a sink. So you need to draw the sink signal. So draw it, something like this. Okay, so amplitude is, it's the 0 point. This one is at omega. The amplitude is A T. So amplitude here is A T. Okay, follow? Okay, and this point here is pi over T. This point here is minus pi over T. So if you want to draw sink, just draw 3 points saja. So these are the 3 points. Where is the point? It's this point. 1, 2, 3 only. Okay, but you need to draw it in terms of the sink graph. Okay, understand that? But actually this explanation is same like this, but this one I didn't draw it out lah. So I feel that student maybe cannot grasp it, so I'm drawing it. Okay, boleh faham at the back? Right, so I'm just explaining this slide actually. Okay, and based on this, if you look at the next slide, it's actually explaining about, okay, that Fourier series coefficient, that what you learned yesterday. When you draw it, you did the coefficient, right? Coefficient, magnitude, positive, negative, and so on. So when you do the line like this, we call it as the envelope. Sambung surat lah, envelope. You put in, it's a line lah basically, envelope. Okay, and it says here is that when you increase the t value, okay, so basically it will decrease the envelope. So this one is just an explanation of what will happen when you increase the t or the fundamental frequency and you increase the omega. Okay, and if you look at this is important point here. So let's look at the value that you have here. Okay, you have here is that if you look at this is sink, but the label is xt. Is that time domain? Okay, and it's interchangeable basically. If you have a sink in time domain, you get in terms of frequency domain, the answer will be rectangular. So it's interchangeable. Okay, so if a sink is small value, you have pi over omega here. Okay, so basically you have a larger rectangular period. Okay, the period is larger, and then you have a larger sink. Okay, the pi over t over here, pi over omega over here. Then you have a smaller rectangular and so on. So it become smaller lah, rectangular. So this is just explanation of the width of the sink and the rectangular corresponding to the t value. Right. So and in this slide, basically, okay, what actually you're doing is, example, if you are given multiple rectangular signal, multiple rectangular signal. Okay, this one is just the normal general signal. Let's say you have minus tau over 2. Okay, just maybe a bit hard. Trying to, you prefer me to use whiteboard online or whiteboard, real whiteboard? Online can have recording, because that one no recording. Online. Because I prefer online also, because I look at student, I don't know if they will revise or not. One time here cannot revise, so better do online. So let's look at this. So I'm trying to explain. Okay, I'm going to explain of the slide already have the answer, but I believe that students still don't understand how you are going to substitute the value. Some students can get it very fast, but some students maybe have time to actually understand it by themselves. So I'm going to do it one by one. Okay, so if you look at this, so we do the first example over here. Okay, the first signal. Okay, draw it together with me. So you have a 0, you have the rectangular. So rectangular signal is given by minus. For this case, as I'm going to write is in T, capital T, minus T over 2, T over 2. Don't get confused. In the slide, I write it as tau. But it's the same thing. Means that the tau in the slide is equivalent to T. Okay, so don't get confused. Okay, but in order for me to actually explain it easier than me, I'm going to use capital T. Why? Okay. Why? Kena sengih pula dah. Okay, so T, draw it properly. You have xt, T. Amplitude, what is amplitude? A. So I'm just writing the graph again. So according to Fourier transform, you are going to use the table number 17, right? So 17. So the equation is given by what? If you have a rectangular, what? T over tau, you will get a T sinc omega T tau over 2. So basically this is the Fourier transform. Okay. So what we are going to do is that we are going to use the equation. So from here, the easiest way is that list out first what is the value that you have right now. Okay, what do you have? Do you have A? Do you have A? Okay, let's say for all the example, A, we keep it A, we don't substitute with 1. Okay, so A is A. Okay, what else do you have? T, right? Oh, that's wrong, That's wrong, It's a capital T, Okay. So we have T. So what's the value of T from this graph? T equal to what? 1. Everyone understood why T is equal to 1? Right? 1. Reason why? Because you have this signal. This is 0 to minus T over 2. And then you have positive T over 2. That's why this period is T equal to 1. Okay, so what you do is that just substitute in the equation. So basically, how you write it is that A, for this answer is A rectangular, okay, T over 1, okay. The answer you get is, you're going to substitute the T value. So A, T is 1, sinc omega, T is 1 over 2. So you get A sinc omega over 2. Okay, so this is the answer over here. Okay, so if you follow through all of the example over there, okay, do you want me to go through all of it? So very fast, we do it. So 0 for this second signal, you still have a rectangular, but the period is from minus T to T. Amplitude is still A. So just directly, what do you get? So if we have the equation xt over here, so we can write, basically we write the answer. Let me just write properly. X omega equivalent to Kenapa? Hilang ke? Dia hilang ke? Dah banyak sangat rehat lah. Cuti banyak. Okay. Cuti banyak sangat. Okay. So, this one, second one, directly, I'm going to write directly. So, X omega equivalent to, what's your A value? A. Still A. Sinc omega. Okay. Refer to the original equation. Original equation, what is it? This one, right? This one. Okay. Oh, sorry. You have AT, right? I forgot about that. So I'm going to write the full equation. AT sinc omega t over 2. So what's t value over here? T equal to 2, eh? Okay, so substitute that, you have a 2 sec omega 2 over 2. So you get 2a sec omega. Right? Okay? And so on. Do it by your own lah, eh? Okay? So this one is simple. Okay? Boleh follow, eh? So for the other is that for the other example, the period become minus t over 4 here. Minus t over 4 to t over 4. So basically, what is the t value? T is equal to 1 over 2. Eh? And then the last one is that you have a rectangular from minus 2t to t. So basically, you have t equal to 4. Just substitute it, you get this one. Reason why I'm telling this. There is a reason. You might where's the example? You might have something like this. Okay, given xt, or in this case is given ft, this signal. Okay, you have different rectangular, right? Different rectangular. So how to answer this later lah. We haven't reached here. There are so many ways how to answer it. Option 1, option 2, option 3. Okay, the easiest option is that by doing linearity. So you know that this signal is by adding this signal plus this signal. Okay, so you need to get the Fourier transform for the first signal, the orange signal. Then second one, you are going to get the Fourier transform for the second signal. Then you use the Fourier transform to get the signal for both lah, and then you get f omega. Okay, so this one is example. So reason why we are doing that exercise just now, this one, okay, so you can just go through it. Okay, so this one is one example. I think we can complete this very fast. This one is simple. Okay, so this one. Okay, so what we are going to do is that we are going to prove, okay, as you know, student might ask, Doctor, why we need to do derivation everything, but in the end, we can refer to the table. Just proving only one equation. Later, after this, use table directly. But to prove that, what you have learned using the equation, because you know that for Fourier transform, there are two equations. Okay, but most of the time for Fourier transform, you're not going to use the equation. You're directly using the table. Okay, so for this case is that if you refer back, okay, to the two equation, this one, okay, there are two equations for Fourier transform. First is Fourier transform and Fourier inverse Fourier transform. So we are looking only at the first equation, xj omega. Okay, so by having that, okay, now example 1 is given an aperiodic pulse function. Okay, they call it pulse because it's one pulse like that lah in terms of continuous time. Okay, so and the pulse function is you have xt given by 1. So basically what it says there is this a value is given by 1. Okay, and it has the period from minus tau over 2 to tau over 2. So basically t here is what? 1. Okay, so in this case is that they ask you to find the Fourier transform the adverse signal. So basically one easy way is directly using transform the Fourier transform table. But for this case that we are using this equation. Okay, so equation to find Fourier transform is we have x j omega, okay, equivalent to integration of minus infinity to infinity, x t e minus, correct or not? Minus n. Minus j omega t dt. Right? So, similar like yesterday, what did we do? We need to identify the signal where it have the magnitude or amplitude. So, for this signal, you have amplitude only at a value and between minus t to t over 2. So, this will be where you substitute the value minus infinity to infinity. Okay, so integration of what? Minus t over 2 to t over 2. Amplitude. For this case, I'm going to stay with A because I'm going to prove that what we derive later will be the same as the continuous time table. Continuous time Fourier table. So xt is equal to A. Okay, so A E minus J omega T dt. Okay, so what do you get if you integrate? How do you do this? So we have a constant, right? So take it out in front first so that you don't get confused. So A integrate between minus t over 2, E minus J omega t dt. So yesterday what you have learned, if you want to integrate exponential, what is the equation? AT is equal to EAT over A, right? Okay, so can you answer this? So A, you get? So what is A in this equation? So your A is here. Not including T. Okay, not including T. Okay, only minus J omega. Okay, so you get E minus J omega T over minus J omega. Okay, in bracket T over 2 minus T over 2. Okay, what do you do next? You're going to substitute the T value, right? Okay, T value, what does it mean? This T value. This T value. Okay, with what? With this 2 value. Okay, so you get A, E. If it's confusing you, then this take it to the left first. Okay, so A over J minus J omega square bracket. Okay, E minus J omega T over 2. Okay, minus E minus J omega minus T over 2. Okay. So, what does it look like? So, you can basically use Euler, right? Euler identity. What Euler identity that you can use? Sine, right? So, sine. So, sine Euler identity is given by what? Sine theta equivalent to E J theta minus, okay, testing only. Okay, 1 over 2j in bracket E J theta minus E minus J theta. Correct? Okay, so you're going to actually rearrange. Why I say rearrange? Because you have minus, right? Okay, so rearrange it So minus minus you got positive, right? So negative, positive, and positive part you need to have positive here also. So you're lucky that this one you have minus negative here. Okay, so it become positive lah. And so rearrange it directly. So you have A over J omega. Okay, E become positive because of the negative over here. Minus J, not minus, positive because you already get the positive point. Omega T over 2. Okay, minus E minus J omega T over 2. Okay, so you want to leave it in terms of sine theta. So do you have J over here? What's your theta? This theta. Theta in this equation is J omega T over 2. So do you have J omega T over 2 down here? Sorry. No. Do you have 2J over here? You have this one 2J, right? So you have J. Do you have 2? No. So what do you need to do? Multiply both sides by 2 over 2. So multiply that, you get A over omega. Okay. I'm going to take it out so that I have 1 over 2J. This becomes 2A. Correct? And then EJ omega T over 2 minus E minus J omega T over 2. Alright? So now, what do you get? So you get 2A over omega. The other can follow or not? It looks like blank already. The front Indian guy here, Suresh and gang. Huh? Delta? Here. Delta. Or what? This one. Omega T over 2. Omega T over 2. Okay? Follow je. You don't substitute anything yet. We just expanding it, right? Okay, so this one become sine. Okay, what? Theta, right? Why I write this one is for you to easy to write it out. Okay, sine J omega. Why my omega become like that? Omega J T over 2. Why have J Okay, this one ke you tanya? Betul. I yang silap. Okay, no J Alright. This one theta, right? Not including J. I write it wrongly. So, correct. Sure is correct. Okay, anyone else want to correct me? No, Okay. So, he's correct. I wrote it wrongly. So, in the end, you get 2A over omega sine omega T over 2. Okay. So, but are we finished yet? No, because we want to represent in sync. So, sync, for sync, you have the equation as a sync theta equal to sine theta over theta. No, it's not me. It's not me who corrected it. It's the it's the whiteboard directly. Okay, sin theta over theta. So, where's your theta? Oh, dah ngantuk dah. Okay, this is theta. Alright. So, you want the lower part here is omega T over 2 Huh? Betul tak? Okay, so basically Okay, you only have omega, eh? Right now, you omega. So, you need to multiply both sides by T over 2, T over 2. Okay. What do you get? 2A T over 2. Okay. Omega T over 2 sine omega T over 2. Kan? Betul tak? Siapa nama eh? Huh? Butayan. Bangladesh? Bangladesh ada? Bangladesh ada eh? Ada. Okay. Okay. So basically you can cut off where you can cut off eh. So 2 and 2 cut off become 1. Right? So you can now write it out as A T sinc omega T over 2. Oh sorry lah, my omega today is like cacing. I don't know why. Sinc omega T over 2. What did you just do eh? Is it we just prove that using the equation, this equation of Fourier transform, we just prove that the table, right? Because why? According to the Fourier transform table, is if you have rectangular, okay, is given by AT sinc omega T over 2. So this is the proof, just to prove it. Okay, but of course for the other we are not going to prove it because we don't have time. Okay, so but if you are interested to see how it's been proved, okay, example, we are going to finish for now. Okay, at night we continue again. Okay, so what we just proved is for this equation, okay, T sinc omega T over 2. Okay, but if you look at the other exercises, okay, even in my notes already have the same thing, eh? Okay, so example, you have exponential signal. Okay, example 2, xt given by exponential blah blah blah. Prove the equation using Fourier table. Okay, but you can look at my solution, it's already in the slide. But what I'm saying is that for exponential signal, if you have exponential signal, the table is given by Fourier transform table. Directly you get x d omega equal to 1 over a plus j omega. Okay, so if you look at the table, exponential is at number which one? Is number 3, eh? Sorry, number 1, eh? Okay, this one. So the solution that I have in the slides, prove it. Just go try to follow it and understand why it come like that, and this is how you prove it. Okay. Previous classes I did the proving, but because we don't have time to really do all of it, okay, so I'm just going to ask you to just go through it by your own, eh? Okay, and this is also for same thing if you have modular for both sides. Okay, so the modular is like this. So what equation? Right. So for tonight we are going to do this one already done just now. We are going to do the Fourier transform property. Eh? So property basically by applying the understanding of transformation that you did, scaling, shifting, and linearity. So we are going to go through it. Okay, so this one will be tonight, eh? Class face to face at library. Eh? That be all for now. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.